Welcome back everyone to the Hello World Guy. This is another episode of the 3D renderer series, and in this video we are going to get started creating some actual stuff on the screen, but we won't actually have anything displaying by the end of this video because modern OpenGL requires a lot of setup. So currently we'll just write two shaders and we'll get into them in a second, and in the next video we'll use some vertex data and use those shaders to render it. So in order to understand shaders, we first need to understand the OpenGL pipeline. The idea is that this is the OpenGL pipeline, and we basically pass OpenGL a bunch of vertices or points, and OpenGL takes those vertices and does a bunch of processing on this. So we take these vertices, and you can see that OpenGL does a lot of different things here, and the blue boxes represent the things that we are going to program on our own. So the vertex shader and the geometry shader, and this the third one is known as the fragment shader. These three are shaders that we can program and tell the graphics card to do what we want. And OpenGL provides no default shaders. This is the shader pipeline or the modern pipeline, which allows us to basically define different shaders to do different stuff, and provides a lot more freedom, but it's also more difficult to set up. But the older one was a fixed function pipeline which did everything on its own, lighting, shadows, everything, and we could not really change or improve the look of our scenes, but we could set them up in a few seconds. But we could just use two functions called GL begin and GL end, and between that we could just provide a list of vertices and it would automatically do that. But this is not what we can do right now. Here we'll have to use the modern pipeline, and it requires a bunch of setup, but it's going to be a lot better in the future when we want to add more advanced effects, or we want to basically do things in our own way. And it's also going to be a great learning opportunity, and modern applications of course use the modern OpenGL. The fixed function is quite obsolete right now, so we should focus on the modern pipeline OpenGL. So this is the idea. We first write a vertex shader that transforms the vertices and tell OpenGL where the location of each vertex is supposed to be, and the geometry shader can do additional processing on the vertices. Like you can see in this example, it splits the triangle into two. This is optional and we won't be implementing the geometry shader right now, and the fragment shader is needed, which basically tells how to color each pixel. So currently what we are gonna do is we are going to get started creating a very basic vertex shader and a very basic fragment shader. Now, vertex and fragment shaders are written in a special language called GLSL, which is very similar to C. So if you know C or C++, it should be pretty similar. And the problem is that these shaders are compiled by the graphics card. So right now I'm writing this program here, and the computer compiles it and stores it as an executable. However, the vertex shaders in GLSL, the OpenGL Shading Language, are compiled by the graphics card. So we actually store the text of the program here, and then each time we run the program we compile those shaders using the graphics card. So yeah, let's go and basically write a shader inside of this program. We basically will write the whole shader in a string. Of course, for more complicated shaders we like to for example have a a separate thing here. So like we could add a separate shaders folder here, and we could read those shaders in a text file, and then we could just use those to compile. But for now let's just do it inside of here. So OpenGL expects the code that we give to the graphics card to be as arrays of characters. So we are going to create a standard C style string here, a const character pointer, which is how you create a string in like standard C style, called vertex shader, not actually name, vertex shader code. So we are going to do that, and our code is going to span over multiple lines, and of course we can't write it in a one long string. So what we can do is we can, for example, put a /n here, and we can basically do this here, and we can just go on the next line and do this. So what would happen is that the compiler will automatically combine these two strings together. However, it will not add a new line, so we'll have to do that manually, but it will automatically just combine any strings that don't have anything between them together. So So that's pretty awesome. And we are going to say here the first line of any OpenGL program must be the version. We are going to use version 330, which means 3.3. So and then we are going to say core. What this means is that we are using the core profile or the modern function pipeline here, not any of the old stuff. And we are going to be using version 3.3, which is not the latest version, but it's the basically the version that we need for modern stuff. We don't actually need any version higher than that. So that's going to do that really awesome. And the next thing we want is, of course, we want some data. So what we want is we want to take whatever the position of the vertex is, and then we want to transform it to whatever we would like it to be, and then we are going to pass it there. So for that we are going to say layout, and then for the location we are going to say location is equal to 0. So we'll basically be getting all of our information as an array. So we'll have to say at location 0 we will take a vector 3 in called position, and this will represent the position that we actually pass from our main program. And we will get that position, and every shader program must have at least a main function. So for that you might say int main, but it's actually void main, because we don't return anything. So we'll say void main, and every vertex shader is required to write to a special variable. So we'll just put parentheses here. You might be tempted to go and on the next line, but since it's really simple, let's just put it on one line, the whole main function. So what we are going to do is we are going to say gl_position is equal to the position that we got, and this gl position is a special variable which represents the position of the vertex that we are supposed to give out. And OpenGL requires that a vertex shader writes to this value, else it won't work. Now you might just say it like that. However, there is a problem with this approach, which is that gl_position is a vector 4 while position is a vector 3. Now you might be saying it does not make sense for a position to be a vector 4 because it's generally vector 3 position. We can just cast it to a vector 4. The reason it's like that is because of something called homogeneous coordinates. So we are just going to say position and convert it to a vec4, and for the last value, the w value, we are going to pass 1. And this is pretty much it. We have got our vertex shader code done. And let's go and write a fragment shader now. So now let's write the fragment shader. That's very simple. We are going to create another string called a string, of course, called fragment shader code, and we are going to the first line is going to be similar, just hashtag version 330 core, because of course we are using the same version. And for the next line, this shader won't take anything in, but it will give something out, and that out is going to be the color of the fragment. So we are going to give a vec4 which is the color representing a red, blue, green and alpha. And we are going to call it frag color, and that's going to represent the color of this particular fragment. And for now we are going to make all fragments the same color, so that we basically get a flat color. And for the main function, we'll just say frag color is equal to vec4, and since we are giving this out, it will automatically go, and we say 1 and 1 on the red and green, and 0 on the blue and 1 on the alpha. It's going to be not transparent at all, but it is going to be yellowish in color. And by the way, I removed that GL clear line so that our background is going to be black. And this is pretty much it for this video. We've created the basic shaders in this video, and in the next video we are going to learn how to compile these shaders and to use them to kind of create some cool stuff on our screen. So we'll do that in the next video. Make sure to like and subscribe, and I'll see you in the next one, and bye.